specimen paper, M1. We're going to start with question 1. A car is moving along a straight horizontal road with constant acceleration. So we draw our acceleration with a double arrow. At time t equals 0, the car passes point P. It has a initial velocity at this point of view, meters per second. After 4 seconds, so a point further down, we have t equals 4. We have travelled a distance of 76 meters. After, now this is key, after a further 219 meters, so that we're going to have to add that on. So 219 meters. It takes another 6 seconds. That means our t at this point isn't 6. This might be a common mistake. It's actually 10 seconds. Okay, so let's take this. Let's look at this in the context of what variables we have, so we know which Suvat equation to apply. Okay, so we know that our time for the first stage is 4 seconds. We know our acceleration is a, meters per second squared. We know our initial velocity is u, meters per second. And we know the distance traveled, so s, our displacement, is 76 meters. Okay, so the letter we have missing here, we have S, U, A, T, so V is missing. So if you look on our equations on the right, we can see the equation with V missing is this one. So let's make a note of that. S equals UT plus a half AT squared. Now if you look at our second stage, so that's our stage 1, and then our second stage, we have a time for this part of the journey to be 10 seconds. We have a total distance is going to be the 76 plus the further 219, which is going to be 295 meters. And that's it. Oh no, what do we do? Well, we've identified an equation. There's 4 variables in it, and we know 2 of the variables. But we know 2 sets of 2 variables. So that means that we can use simultaneous equations to generate 2 versions of this and then solve them using simultaneous equations. So let's plug in stage 1. So S is 76 meters. T is 4, so that's going to be 4u. And t squared is 16, so half of 16 is 8, so plus 8a. Doing the same for the second stage, total distance is 295. Time is 10, so 10u. And a half of 10 squared will be a half of 100, which is 50a. If you solve these 2 using simultaneous equations, you could maybe turn both a's into 200, or it might be one way of doing it, or turn the u's into 40. Either way, you will solve them and you will get u equals 12 meters per second and a equals 3.5 meters per second squared.